Okay, our last part to the L'Hopital notes is what do we do when we have indeterminate forms that are exponential in nature, and how do I turn those forms into the correct form so that we can use the L'Hopital rule? So let's take a look at this first example, which we had showed earlier in the problem. And I had said, hey, I'm going to tell you how to calculate this. The answer is e squared. But what we want to do here, and kind of the technique that we're going to use and the method or the fact that we're going to use is that exponentials, one of the things that with your log properties is that when you want to take the exponent out of the exponent and move it to the front, you can do that when you have your log property. If you were to take the log of something, and I have the log of, say, 10 squared, that's the same as 2 log of 10. And so what that's going to do is we're going to do this idea that this log property, if I can take the log of this expression, then I'm going to be able to move the exponent from the exponent to be a product. And then once you get it to a product, then you'll be in a product indeterminate form. You can change it till you get into a fraction quotient indeterminate form to get us there. So we kind of have to do two transformations on this. So the fact that we're going to do is that this limit right here is going to be equal to some answer L, which we don't know what it is yet. But what we're going to do in step one is we are going to use the log property to help me out. I am basically going to take this equation that I have here. You say, hey, this is equal to L. I'm going to take the log of both sides. So, and I'm going to do natural log because I like that better. So the natural log of L, of the limit, the answer that I'm looking for, is going to equal the natural log of this limit over here. And this is all good because the natural log is a nice function. It's one-to-one. The composition rule about calculating limits is that you can figure out where the limit of the inside goes, right? And if this goes to L, then this would equal the natural log of L. So that gets us to here. Now, the fact with these limits that allows us to do this is that the natural log of a limit is the same as taking the limit of the natural log. Now, initially, I'm going to write all of this, and then we'll start skipping some steps in the next example because you don't really need to write all this once you see what's going on. So we would have the natural log of 1 plus 2 over x to the x. So that's the fact that we're using, okay? So then we come down here and we use the log property. I'm going to take my handy little exponent right here, and I am going, like, oh, because what in the world did I just do? I want that. I want this. Let me undo. There. So that x right there, I want to take that and I'm going to move that to the front. Whoops, not to the front of the inside. Move it all the way to the front of the outside out here because of this log property. And you're like, well, why does that help me when we're doing it? Then what we have is the limit as x goes to infinity of x times the natural log of 1 plus 2 over x. Now, when I do that, now if I check my indeterminate form and see what form we're in, again, I'm just going to write form right next to it. Actually, let's write it over on the other side, planning ahead so I have room for the other one. So my form is going to be infinity times, as this goes to infinity, that goes to 0, this goes to 1, natural log of 1 is 0. So I went from an exponential form that I started with to a product form. I still can't use L'Hopital yet, but I can fix this problem using the technique that we had in the last video. So I'm better. I'm not there, but I'm better than I was. So then we take this x, and remember, you can always take a product indeterminate form and turn it into a fraction indeterminate form simply by using negative exponents. So I'm going to make that x to the negative 1, right? Just move it to the bottom by putting a negative exponent on it. And then, and remember, this is 1 over x. If you want to write it as 1 over x, that's perfectly fine too. 1 over x. And then you say, okay, now what indeterminate form am I in? The top is still going to be going to 0. The bottom, 1 over infinity, is now into 0. So now I've got it into the correct form. Now we can use L'Hopital. So we can go ahead and we can take the derivative. So I'm going to go to my derivative using L'Hopital, derivative of the top, derivative of the bottom. X goes to infinity. 1 over the stuff times the derivative of the stuff. Remember, this is 2x to the -1, so it would be negative 2x to the -2 over x to the -1, which would be negative x to the -2. And you're like, okay, I got myself to there. I see a nice little, I can cancel this and leave a 2 and cancel it with that. And so that's going to help me if I check where I'm at now in my form. As you go to infinity, this goes to 0. 1 over 1, and then this goes to 2. So you get to there and you get 2. And then you go, wait a minute, that's not the answer we got when we did this in the beginning. It actually went to e squared. Well, that's because look at what we're equal to here. Step 1 in this technique is to use the log property. But there's a step 2 is that if you put the log in, remember what we found is that the natural log of the limit I'm looking for is equal to 2. So step 2 is find L. You have a kind of two-step process. So e squared equals L using your log properties, and now we're done. So our original limit that we were calculating from the beginning is going to be e squared. So this equals e squared. So step 1, use the log property to calculate the limit. Step 2, find L by using your rules for your exponents. All right, let's take a look at the next one. Do another example. Okay, again, we're in the form 0 over 0, exponential indeterminate form. So we know that what we need to do is use the log property. So step 1, use the log property. So I'm going to take the natural log, I like to go equals L. So the natural log of L equals, and I'm going to start skipping some steps. I could write natural log of the limit, then I can move the natural log inside, and then I can move the exponent to the front, or we can just be like, the whole point of this is to move the exponent to the front. So now we're going to have the limit as x goes to 0 from the right of our x times natural log of x. So I took the log of both sides, put the log in the limit, move the exponent down from the power. So that gets us to here. Then we go ahead and we calculate, we see where we are, we plug in 0. What form are we in? 0 form. 0 times, and then when I go to 0 on the right, this is negative infinity. Indeterminate form, that is a product. So I'm like, okay, I can't use L'Hopital yet. I'm better. I went from exponential to a product form. Now I'm going to use the negative exponent to move something to the bottom. I'm going to have ln of x divided by 1 over x. If you check your form, now you're going to have on the top, as you go to 0, you're still going to be negative infinity. On the bottom, as you go to 0, now we're going to be infinity. And so we're going to get infinity over infinity. Now I can use L'Hopital. So we're going to take our derivative. So all of this is just getting us set up to use L'Hopital. Take the derivative of the top. So limit as x goes to 0 from the right, 1 over x. Derivative of 1 over x, or x to the -1, negative x to the -2. Again, when I get to here, you still have infinity over infinity, but I can combine like terms or combine powers together. This is x to the -1 over negative x to the -2, which is going to give me the limit as x goes to 0 from the right. -1 minus -2 is actually going to flip up and give me negative x. And now I don't have an indeterminate form anymore, so we can calculate this limit by plugging and chugging. It's going to equal 0. But remember, we have step 2. We are not done. What we just found is that the natural log of the limit is 0. So we need to go e to the 0 equals L, and e to the 0 is 1. So the limit is equal to 1. And I will let you verify that when we are calculating this, like if you want to, you can go ahead and graph this and verify that these are the correct limits that we're going to be looking for, right? And we'll do one more example of this. Example 8, we're going to skip because that would have to be after we do chapter 5. So we can kind of cross that one out. So let's do this last limit, and then we'll be done with our L'Hopital notes. Again, indeterminate form. Oh, shoot. I just realized I had the wrong indeterminate form arrow. I should have gone from this form to that form. All right, so indeterminate exponential, I'm going to use my natural log. So step 1, use the log property. State that's equal to L. Go the natural log of L equals the limit as x goes to infinity of 1 over x natural log of x. Then just go straight there to that third step that we had over here. So I took the log and then I moved the 1 over x down. I write it right there. All right, we check where we're at. 1 over infinity is 0. Okay, so my form at this point is going to be 0 times, as you go to infinity, that goes to infinity. So I went from exponential indeterminate to a product indeterminate. So we keep going. 1 over x, I can actually just put that, I mean, it already is a fraction. Why don't we just go ln of x over x, combine it together to be a single fraction. We check our form. Our form at this point is infinity over infinity. Now we're in the correct form. We can use L'Hopital. So we take our derivatives. So 1 over x is derivative of natural log over 1. And then we get 1 over infinity, which is going to equal 0. And then remember, last step, we have to, step 2, that's the part that you forget all the time. That's the ln of L is 0. E to the 0 equals L, so L in this problem is also 1. All right, and so that will finish up our L'Hopital notes. So moral of the story is that you can use L'Hopital provided you are in the indeterminate forms that you are allowed to use L'Hopital, which is up here at the top. You have to be in one of these forms. And if you're not in those forms, then you want to make your expression turn into those forms by some magic of some algebra or this little technique, which is called using the log property in order to rescue us and get it there. You only take the log of both sides if you have exponential forms of indeterminates. If you have, like if we go back to the previous example, which down here at the bottom, that if you have product indeterminate form, then use a negative exponent and move things around to get yourself into a fraction. And then if you have a sum or difference form, then typically you just need to get a common denominator and combine them together. So you have to get it into the correct form before you can use L'Hopital. All right, so that gives you a new technique that you are going to use. A comment about L'Hopital is it's a technique and a topic that they just brought back into the AP. And so I'm going to put a star by this one and say that this, let's go back to the very beginning set of these notes, that this is a definite FRQ this year. It was one of those things where it was not a topic for a while. And so they took it out of the AP curriculum for AB, and it was only in the BC curriculum. They've put it back in. They had kind of a test year or two where they were piloting the questions. Sometimes they have test questions on the AP that don't count. But this is the year where I can guarantee that because it was something that was new that they brought in, that we're definitely going to have some FRQs that are related to L'Hopital. And when we come back, we will take a look at some examples. We'll pull some from the BC class because that's where we're going to have some examples that they've used FRQs on L'Hopital's rule before and show what types of questions you might see on the AP for that. But it's definitely a topic that, in terms of putting your applications in a place where you're going to have those to study, especially going into the AP. We're in that time now where these are the types of questions you'll see in the free response section. So you definitely want to study this. So L'Hopital's rule, find that. You have the worksheet, so go ahead and work on the worksheet, and then we'll come back in and when we get to class and process and see if you have any questions.